We're going to be looking at properties of exponents and scientific notation. So one of the rules I like to use for simplifying is this phrase, when in doubt, write it out. If you're not sure, we'll write everything out. We're going to evaluate expressions here of exponential expressions. Right now, the 4 is considered the base, the 3 is the exponent, and that exponent tells you to take the base 4 and multiply it to itself 3 times. So when in doubt, you write it out. Then multiply it out. 4 times 4 times 4 is 64. 2 to the 4th, that's going to be 2 times 2 times 2 times 2. These 2's multiply to be a 4. These 2 are a 4. 4 times 4 is 16. 7 to the 3rd power, 7 times 7 times 7. That equals, I believe, 343. Okay, number 2, please star these examples. These are trick questions. Here we have a negative 5 squared. Here we have the quantity negative 5 being squared. Notice I said quantity because it represents the parentheses. By definition, this negative 5 is negative 1 times 5 to the power of 2. So if you think of orders of operation, we have to do exponents first. 5 squared, that's 5 times 5. That's 25 times the negative 1. You get a negative 25. The quantity negative 5 squared, now the whole set of parentheses is the base, whereas up here it was just the 5. So now we write the parentheses with the negative 5 twice, multiply that out, a negative times a negative is a positive 25. Number 3, without using a calculator, evaluate these expressions. Here we have a negative 2 in parentheses to the 3rd power. We're going to write it out 3 times. A negative times a negative is a positive times a negative is a negative. 2 times 2 times 2, we get negative 8. Now here, be very careful. Do not say, oh, look, a negative and a negative, make it a positive. You have to write out the parentheses 3 times. So I have a negative times a negative is a positive, negative times a negative is a positive times a positive, it's a positive. So this comes out to be a positive 8. And now people think, well, why can't I just go a negative and a negative as a positive? Well, now if I change the power to a 2, this negative 2 is written twice. Negative 1 times a negative 2 times a negative 2. There's 3 negatives. Now my answer is negative 4. You cannot simplify those negatives right there because 1 is being affected by a power, an exponent. Number 4, we're going to multiply the 3 times the 2 to get 6r. If we have more variables, think of it like this, negative 2 times c times w. Put all the coefficients first and multiply them together, and then just put your variables in alphabetical order. Properties of exponents. Our first one's called the product rule. When I multiply like bases, you keep the same base and you add the exponents. What quotient rule? When I divide like bases, now I subtract my exponents and still keep the same base. Power rule, I have x to the m power, all that to the n power. Notice the difference here is there's 2 powers and 1 base. You multiply those 2 powers or exponents together. Zero exponent rule, b to the 0 is equal to 1 as long as the base does not equal 0. You can't have 0 to the 0 power equal a 1. My negative exponent rule, there's 3 versions. If I have x raised to a negative power, think of it being written over 1. You can move the base with the exponent to the bottom and then change it to a positive exponent, which is going to be very helpful when the directions are going to say simplify and use positive exponents in your answer. If I have x to the negative n in the denominator, then you can take the whole base from the power, move it up to the top, and change it to a positive n. If you have a fraction written to a negative power, the negative says you can flip the fraction and then apply the power as a positive one. All right, simplifying. Here we have 9x cubed times 2x to the 4th. So like we saw earlier, think about bringing the coefficients together. 9 times 2 is 18. X to the 3rd times x to the 4th. I'm multiplying like bases. Add the exponent 3 and 4 to make it x to the 7th. Number 8, mark as a trick question. This is the power rule. We have y to the 3rd to the 4th, and there happens to be a 3 in the denominator. You have to put a power on the 3 and call it a 1. You have to give it the exponent of 1, because exponents can only be multiplied to exponents. This 4 times 3 would give me y to the 12th. This 4 times 1 is going to be a 4, which is now 3 to the 4th, which I would then simplify to 81. Now, if you forget the 1, a lot of people will make this mistake and take the exponent 4, multiply it to 3, and call it all over 12. Well, 12 is a far cry from 81. Number 9, simplifying here, we have 2z to the 3rd, all to the 4th power. Again, there's no exponent on the 2, put a 1 there. The 4 gets multiplied to the 1 and to the 3. So 2 to the 4th times z to the 3 times 4, 12th. And you can simplify 2 to the 4th. We had that earlier. We called it 16. So 16z to the 12th. Again, number 10 is just like number 7. Bring the coefficients together. 9 times 3 is 27. Y to the 10th times y to the 5th. Multiply like bases. Add your exponents. Make it y to the 15th. And it doesn't matter how many bases that you have to multiply. Take the 4, the 7, and the 6. Bring those all out to the front. Z to the 9th, z to the 7th, z squared. So we want to multiply 4 times 7 times 6. That's 168. And then z times z times z. Take all these powers, add them together. That'll be 9 plus 7 is 16 plus 2 is z to the 18th power. 12, here we have the quotient rule. I'm dividing like bases, so subtract the exponents. So x, 20 minus 7 will be the 13th power. 13, here's again one of those trick questions. Put a 1 as the exponent on the 4. 3 times the 4, 3 times the 1. Z to the 12th over 4 to the 3rd. 4 to the 3rd, I think we saw that earlier, that's 64. 14, or quotient rule again, now you have two bases. So dividing like bases x, subtract 33 minus 13. Subtract, or dividing bases y's, subtract the powers 49 minus 11. 33 minus 13 is going to be x to the 20th. 49 minus 11 will give me a power of 38. 15, here we again, power to a power, but no exponent on the 3 and the 5. Make sure you put them there. The 2 can only be multiplied to the powers. 3 to the 2nd power, 2 times 1, 2 times 4, y to the 8th, 2 times 1, 5 squared. Simplify those numbers. 3 squared is 9, 5 squared, 25. Okay, 16, simplifying this expression. Work the coefficients first. 30 over 14, they're both even numbers. Reduce them by a 2, that's 15 over 7. X to the 19th divided by x to the 8th. Keep the x and subtract the powers because you're dividing. Y to the 15th divided by y to the 6th. Keep the y, subtract the powers. So that's 15 sevenths, x to the 11th, y to the 9th. 17, simplify the expression. This one, you cannot touch the x's and the y's and the z's and start subtracting powers because they're both raised to the power. So one way we can simplify this without doing a lot of work is focus on my x's. This 6 gets multiplied to the 4. This 5 gets multiplied to the 5. That's x to the 4 times 6, and because we're dividing, we minus 5 times 5. Now for the y's, 6 times the 4, y to the 4 times 6, 5 times the 4. We're dividing the y's, so you subtract those power representations. Now we could multiply this out and go 24 minus 25, 24 minus 20, 6 times 5, 30, 5 times the 1 is 5, and then subtract the powers. That's fine. So 24 minus 25, 24 minus 20, 30 minus 5. We have x to the negative 1, y to the 4th, z to the 25th. Now here they'll probably ask you to write your answer with positive exponents. So take x to the negative 1, put it in the denominator with a positive 1 as an exponent. You can put the 1 or you don't have to put the 1 as the power. They both work. 18, don't make this mistake and think that, oh, I can add the powers. No, you cannot. You literally have to figure out 7 to the 3rd. We saw that was 343. 7 to the 5th is 16,807. You add the two together, 17,150. Probably the most straightforward way of doing that problem. Please don't copy this down. I think it's a little bit out of our scope. We haven't talked about factoring yet. When we do, I'll recall this problem for you. Simplifying 2 to the negative 2, negative exponent takes the base 2, puts it in the denominator with a positive 2 for a power. 2 squared is 4, so this is 1/4. 20, dividing like bases, subtract the powers. Negative 4 minus 2 is going to be 4 to the negative 6, and that moves it to the bottom. Or you can move the 4 to the negative 4 to the bottom, and then multiply like bases and add the exponents to get 4 to the 6th. Either way, you get the same thing. That's the one thing that's really nice about exponential rules, is there is no set order. I have found that most students like to get rid of negative exponents, make them positive first, write their 4 to the 6th, then we can go to the calculator, find out that's 4,096, and write our fraction as 1/4096. All right, so that's part 1.